So fine. So today, what we'll do is we'll start with some with the collection framework. Okay. Fine. This collection framework is basically it's for data structures. Most of the data structures are available from the collection framework. Okay. Fine. What kind of data structures we know about? List, linked list, right? I think those are the kind of hash table, right? Okay, so yes, we have queues, right? Queues, stack. So as far as these kind of various kinds of commonly used data structures are concerned, we have a package, and we have something called a collection framework, which takes care of defining all the various kinds of data structures. Okay, fine. This collection framework was introduced in Java 1.2. Okay, it's not that before Java 1.2 we didn't have data structures in Java. Okay, fine. There were data structures being used right from the beginning. Okay, but what the collection framework has done, it has defined a uniform way of using the data structures. There is some standardization which has been done here. Okay, because you know what would happen? A data structure means someone would go only for a class, right? Let's have a class for a particular data structure. And then in that data structure, whatever operations have to be supported by that data structure, you would put the methods in them. Okay, and for a very similar data structure, you would again have another class, right? And which has its own set of methods, because it has been, the two have developed it independently. At one place, to add an element into a structure, you would have used a method called add. Another one would have said, okay, let me use a method called put. Fine. So there's no standardization in that case, right? So to get that standardization, what has been done here, we have used the collection framework defined the data structures in terms of interfaces. Okay, so you have interfaces initially, and then we have the classes which implement an interface. Okay, so a very similar kind of data structure or anything, or they have the same interface. They implement the same interface. So we have that same standard set of methods. See, for the same data structure, right, you would write one implementation which is good with smaller, when you have less number of elements, and something which is more efficient when we have more number of elements. So there will be two different implementations for the same data structures. Okay, so it's a good idea to always use interfaces in such cases. Okay, so collection framework main idea was to have standardization, and once we have a standardization, okay, then it's also possible to have interoperability between the data structures. Fine, you can have interoperability between the data structures. So that's also another aspect of why the collection framework came. Okay, with these purposes it was there. So what we'll be doing is we'll be looking at the various interfaces initially, and then we just need to know what are the classes which implement that interface. Okay, see, always we use the type name as interface, right? See, I declare, whatever is the super type, that's what is supposed to be used here. See, for example, we always declare account, and then we assign a savings account or a current account there, right? But our type declaration, whenever we use a variable name, or we declare it to be of type account. When we create the object, that time we decide, which object it should be. Okay, right? So when you create the object, that time you are supposed to know the class name. Otherwise, always write your code, any variable which you are having, in terms of the interface. Okay, fine. So let's see what is this collection framework. What are the various kinds of interfaces which are there? What kind of things it supports? Okay, yeah. So collection framework, if we start, yes, this framework is, most of the things about the collection framework belong to the java.util package. Okay, so we have the java.util package. I'll just list some of the common interfaces yes, fine, which will be most of the time we'll be going through. Okay, so one of them is the, from the java.util package, we have the most general form of a data structure in the form of a interface called collection. And of course, all of these interfaces here, all of these data structures, they are using generics. So it's a collection of some element type E. Okay, fine. So collection framework is, yes, one of the interfaces here is a collection of E. Fine. The collection of E has a few common subtypes. Okay, one is a list of E. Okay, another one is a set of E. Okay, yet another one could be Q of E, Q of some element type E. Okay, and under Q, now these are all in terms of interfaces, so it's always likely that one of them will have a more than one super type. Okay, so under Q we have something called DQ. Okay, fine. There's another one called the blocking queue. And we have another one which we call as, which is actually a subtype of both of these above. Okay, this is a blocking DQ. It's a blocking queue. It's blocking as well as it's a queue. It's a DQ. Okay. See, blocking queue is a queue. Okay. DQ is also a queue, and blocking DQ is a DQ, which is a blocking, right? Which is a blocking feature. Okay. And so this is supposed to be, and this is a common hierarchy for the collection. Okay. Another one is where similar to the hash table, which we know of as a data structure, something on those lines. So again, an interface called map. Okay, this uses, when we use hash table, there are keys which are supposed to be there. So it uses a key type and a value type. There are two types of objects, key and value. Okay, just one more point here. For a set, another common subtype is a sorted set. And for a map, okay, another subtype is a sorted map. Okay, fine. So this list, what I have given here, is a most commonly used interfaces from the collection framework. Okay, a few things here. This one, the blocking DQ and the blocking DQ, these two belong to actually a sub package. Fine, they belong to a java.util.concurrent package. Okay, so I'll just put the name here. They are part of the java.util concurrent package, whereas these two, they are still in the java.util. Okay, fine, only for those two. Fine. So these are some common interfaces. There are a couple of interfaces more. Okay, but they are not data structures actually, right? But they are something which support various kinds of operations on a data structure. Okay, some common operations on a data structures to work on a data structure rather. So it's available for collection, right? So related to collection itself. So when I say collection, that means it's going to work for everyone. Okay, so so a related interface. Let me put one more interface here. A related interface called iterator of some element type E. Okay, this iterator is not a data structure, but given a data structure, right? Yes, it works on that data structure, right? So basically, what was let me also explain slight history of this in terms of that the collection interface. One of the methods I'll put here itself has a method. Okay. Okay. So there's a method which is saying I'll return an iterator of E if you use a method called. So this is a method in the collection itself. It's going to be available for all. Okay. So what it says, if you got a collection, you got a object which is we call as iterator, which helps you to iterate over the elements of that data structure. Any of these kind of data structures, if you are having, you can create an iterator so that you can iterate over all the elements of the underlying data structure. Okay, so iterator itself is not a collection. That's one thing you should understand. Iterator is not a data structure. It works on an underlying data structure. It has an underlying data structure which it is working on. Okay, and Java 5 provided us with a for each loop. When Java 5 added the for each loop, right? Recollect that for each for, and you give the type name. Okay, and we said, oh, it works for arrays and for anything which is iterable. Okay, fine. So the idea here is we have iterable of E as an interface, and collection is extending this iterable interface. Okay, and what's the method in the iterable interface? Let me shift it from here to here. Okay, and so it's an iterable interface which provides for this method. Collection extends from the iterable interface. Okay, and therefore collection also has this method. What happened was actually other way around. Okay, right. The collection framework did not have the iterable interface. Java 5 came up with the for each loop, and that time they added this interface called iterable. Method called iterator was already existing in the collection. Okay, and it's yeah. So this was introduced to support for each loop. Okay. Okay, and so this will support a for each loop. Okay, fine. Map is a separate thing. Map is not iterable. Remember this. Right? because I put iterable there. Fine. Fine, map is not iterable here. Right? Fine. Okay, so let's go for the methods of collection. Right? Okay. One thing you understand that Java 8 introduced the default and the static methods. Java 8 has introduced the default and the static methods. They were not earlier part of the interfaces. Okay, fine. What we are going to do here is from Java 8, because of the default, find the default things. Many of these interfaces have additional default methods, but they can't add an abstract method, right, in an interface in a newer version. Otherwise, it breaks the backward compatibility. Okay, so there are no new abstract methods which have been added. And so what we do here is we'll look at them from the point of view of the abstract methods initially. And then we'll see what are the additional default methods which came from Java 8. Okay. And so we'll look at the methods in each of these, right? Okay. So starting from the collection, iterable has this, right? It gives us an iterator. And okay. And iterator is giving us a for each loop. Okay. So I'm currently only mentioning the abstract methods and not the default methods in each of these types. Okay, I want to have a look at the type hierarchy in a tree fashion. Okay, we can have a look at it here. Okay. So it's like this. We have this is supposed to be the collection of some type. Right? And this is okay. I'll just put that here. Okay. Above this, yes, we can just put one more type, which is the iterable of E. Fine. This interface, iterable of E. Fine. This actually belongs to java.lang package. Okay. So this is the one which is above this. Okay. Fine. Then on this side, yeah, what are the other things we have? One is a set of E. Okay. Fine. One subtype is the set. Another one is the, okay, below set is the sorted set. Okay. Fine. This has a list of some element type E. Okay. Then we have the Q of E. And below this will be the DQ. One side is the DQ. Other side is a blocking queue. And then what we have here is a two super types. Yeah. Yeah, that's what is coming here. And so this is supposed to be the blocking DQ. E. Okay, and these are the two super types. These are all interfaces. So more than one super type is fine. And so that's a kind of hierarchy in these interfaces. Okay, fine. Iterable, one abstract method. Okay, iterable has one abstract method. Okay. Okay. Fine. And iterable is above the collection. Right? Iterable is just above the collection. And so this is how it is. Okay. Fine. Now coming to the methods of the interfaces, one method we know from the iterable. There's a method called iterator to give us a iterator. We can go through first the method of the iterator itself. Let's see. Okay, so let's put the method list here. Okay. Yeah. Okay. So we start with the, maybe we would like to start with the iterator. Okay. Okay. So what are the methods in iterator of E? Okay. Only looking at the abstract methods. Okay, because there are other methods as well. Okay, so iterator of E has a method called there are there are methods. Fine. There's a public method returns boolean has next. Okay, another one returns E. That's a method called next. These two are the most commonly used methods, but still we have another abstract method, right, which returns I think it returns E, and method name is remove. Okay. So a iterator works on a underlying data structure. There is some data structure on which it is supposed to work. Okay. Okay. There are a few exceptions I must mention here as far as all the collection framework are concerned. Okay. So let me put some exceptions, right? Okay. How will you get an object of iterator? Normally, we would not have classes to implement the iterator. Okay. And there is some data structure. So there is supposed to be some class which is going to implement a method called iterator, and that is supposed to give us an object of the type iterator. Okay. There's no standard class which says, okay, you create object of this to get an iterator. How do you get an iterator? We have classes to implement the collection, list, set, map. Map anyway doesn't have iterator, but when list, set, right, queue, they have this method called, what's a method which gives us the iterator? What's a method? Method name is iterator. So on a collection, if I say I want to call iterator, yes, you'll get an iterator. Okay, we'll see how it is normally going to be used here, fine, from usage point of view. So if there is some, let me now take it as, let's say we have a collection of account, right? Okay, if we got a collection of account, let's say CA is my collection of account. Okay, let's not bother about which, because it's an interface, some class which implements that interface would have been used to create an object. So let's not bother how it was created. Okay, but how I'm going to get an iterator object? I'll get it like this: iterator of account iter equals, we don't say new or anything, ca dot. That's how you're going to get it. And how it will be helpful? Okay, how we use this object? We use it like this: while it has a next. Okay, let's pick out the one account object equal to. So if it has a next element, then I'll pick up that next element and do something on it. You see. Okay. Fine. While working on it, okay, I got one. So this is my current object of available from the data structure. So underlying data structures, yes, the CA here is the underlying data structure, right? Iterator is not the data structure. It is working on the collection which I have. Okay, it's not created a copy of all those account objects. Okay, it's not a new data structure. It works on a data structure. It allows you to iterate over all the elements of a data structure, right? So that's what we are doing, right? Process all the elements of a collection. Okay, fine, I can do it like this. While processing, for example, what I might look at is I'll say, oh, if that account dot get balance is less than 0. Okay, if it is less than 0, right, it can go negative because of the penalty. If it is less than 0, then I want to have it removed from the underlying data structure, right? I want it to be removed from that collection. How will I remove it? We have a method called removeAll even in the collection. But here we have a method called remove. And this is what should be used. Okay, now let me explain one of the exceptions here. Okay, the collection interface has a method called remove also. And collection also has a method called remove. So in collection, I have to pass a parameter, which object is to be removed, right? So if I do like this, this is the correct way. Okay. Okay. Whereas if someone says ca dot remove ac, okay, throws concurrent operation, something like that, it is going to throw an exception. This is supposed to be throwing a exception that there is a concurrent updation happening. Okay. It will throw a concurrent updation exception. Okay, let's see, understand why this happens. Okay. Okay, let's see why this would happen. This happens because it's something like this now. We are having a collection here. See, let's say this is my collection object, which in turn has the various elements in it, right? Okay, this is supposed to be having various elements. Okay, and then when I ask for an iterator, what does it do? It does not create a copy of those elements. Instead, it creates one object. So this is my iterator object, let's say. Okay, that's my iterator object, and this is my collection of account objects. I've asked for it. So what this would do, it would create some kind of an indexing to know all these elements, right? All the elements in this collection that it should know. Okay, right. So it has just created some kind of indexing on them. Fine. Okay, I'm at 0th element or whatever. Okay. Fine. There's nothing supposed to be like when it's a collection, we don't have anything like an index in terms of the data structure doesn't hold a order. It doesn't remember which is a collection is a very general one. Okay, it doesn't know which is the first element or second element. It's not supposed to remember it that way. Okay, no ordering on collection. Okay, now when I ask for it, so this has created its own mechanism for keeping track of the elements in the underlying collection. Okay, fine. Now if I'm asking for, do we have next element? Yes, it will know from that, yes, there are more elements to be processed or not. If you ask for next element, yes, it will give up one element, two element, whatever are there. You're getting those elements. You examined an element and you find that this element is not supposed to be there in the collection. Fine. So if you ask this guy to do it, yes, it will be able to manage it. Whereas if you directly update here and just remove an element, what would happen to the information which it had gathered initially? He will be misled. When this is supposed to be, no, it has taken kind of a picture of this, but now the picture has changed without this one's knowledge. You call remove, he knows about this change now. Okay, so that's the concurrent updation exception. The reason for a concurrent updation exception is this guy, the iterator, is not knowing about the change. You have suddenly changed something. Right? It's not in the knowledge of the iterator. Yeah. So calling the remove method on iterator is what is supposed to be done if you actually are interested in doing that kind of a removal. Okay. Here the exception, concurrent updation exception, that's happening here. Another thing here, because I'm talking about the exceptions here. Okay. Another thing is we have various methods in these interfaces, right? Which talk about what operation should be there on a particular data structure. So a particular implementation may opt for not implementing a particular method. For example, I have got some collection which I feel no updation must take place on this. It has been created with a particular set of elements, fine, but no one is supposed to add a new element or remove a new element. But because it's a collection, the method is available. So such methods will throw a unsupported operation exception. Any implementation may say, I'll throw a unsupported operation exception. I'm not implementing this particular method. I'll be throwing an exception if you call this. Okay. So find two exceptions commonly, which must be understood, right? So they may commonly occur. Okay. Fine. Clear the purpose of those two exceptions. Okay, let's come back to the method list now. Okay, what kind of operations? Let's start with the collection interface now, right? Okay, one more thing. Okay, let me just finish this iterator part. Okay, so this is how it is, how we were using the iterators. Okay, this is how iterator was being used.
So in short, sir, can we say that we are use collection for exception handling?
No, no, no. No, it's not. Collection is not for exception handling, but collection also, exceptions can occur anywhere. So collection also can have exceptions. Okay, so these are some common exceptions which may occur in a collection. Okay, and so, and why they would occur, that's the only thing. Okay, right. Now this is how we were doing before Java 5. A while loop. Okay, unless you want to do something like a removal, okay, if no such thing is there, okay, if this is not there, let's assume, okay, then a better way of using this would be, we can use a for each, because collection is iterable. See, when you do a for each, it's doing this basically. It's doing the iterator has next and iterator dot next. Those two methods are used. Okay. And it's just like a while loop basically. You are writing this for each on anything which is iterable. What is CA? This is an iterable item. It is iterable of account. Because it is iterable of account, I can use it like this. For each account AC in that collection of account. And here is where we will do the, okay. So this is much easier compared to using the iterator. And that's from, but this is available from Java 5. Okay. Okay, let's now look at all the methods of. So we begin with the abstract methods of collection of E. Fine. Starting with the simple operations. Let's see what are the simple operations which we have. If there is a data structure, we should be able to add element into it. It's a collection. So if there is a collection of any type, we should be able to add element.
remove method declare करता है तो उसको specific कुछ element देते हैं कि उसको delete करना remove करना
that is in the collection. Iterator, no, you don't have to mention any element. Right? So you can see here the difference. Right? This is without parameter, right? And here in the from a collection, then you'll ask the collection, this is the one I want to remove. Whereas in iterator, it has already picked up the element, whatever is the current element of the iterator. Okay, so we have public Boolean method called add, which would take the element type, whatever is the element type. It's a collection of account, then account. If it's a collection of string, then string. Okay, and add, what else? If add is there, we should also be able to remove. When we say remove, yes, you may give any kind of object. There's no that it should only be of type E. Okay, you may use any kind of object here. Okay, fine. One thing to mention here is when I say remove, what will it do? Check the elements in the collection. Fine. The first element where it finds equals method returning true. Fine. It is based on equals. It's not same object. It's not the double equal to. It's a equals method. And it uses the equals method. and to find out whether this object is, so first occurrence it would remove. Fine, add, remove, what else do we want? What are the simple operations? Boolean, fine, whether it was able to do it or not, successfully added or removed. Yeah, what else? You add, so there's a collection, so you can add, you can remove, then you can check. Okay, so we have contains, a method called contains, where you can pass any object and it will check whether it is contained or not, when it's there in the collection or not. Contains, then you might like to know how many elements, the number of elements you have in the collection. Then okay, we'll have the method iterator because it's a iterable. Fine, simple operations. And just okay, yeah, very basic things is empty. Okay, is empty returns a boolean, is empty. And oh, you want to empty it? We have the method called so if you say clear, clears all the elements, makes it empty. Fine. Okay, so these are supposed to be the simple operations. We have the array, okay, so the array operations are supposed to be like this. We have a method to return an object array. That's one method. Okay, then we have another method which would return, now this method is a generic method. Okay, so it returns array of t. Right? See, by default, if I just say toArray, don't pass a parameter, then it creates a array of object. What is allocated would be array of object. On that, your elements will be available. Okay, the other method is returning array of t. Name of the method is again toArray. Okay, but here you pass an array as a parameter. Okay, so what is this supposed to do? It has to give you an array of the same type as the one you have passed as parameter, and it should be returning the array of the same type as the one which is passed as a parameter. Okay, now here in case the size of the array which you have mentioned, which you are passing as a parameter, matches the size of the collection, and if the size matches, it will update the array which you are passing as a parameter. Remember, the array which you are passing is also getting updated. The array which you are passing is getting updated. Right? So let's say my collection has 5 elements. Right? Our collection has 5 elements, and you are passing an array of size 5. Okay, if you pass an array of size 5, what will happen? It will populate it with the 5 elements of the collection and return the same array. If you pass an array of size 2, it will update the 2 elements. Fine. Some 2 elements from the collection will be populated there, but now since the size is 5 and all of them cannot be accommodated here, it will have to allocate a new array of the size 5. Okay, and populate all the elements there also, and return the new array. So if the array size doesn't match, or if the array size is smaller, a new array is returned. If the array size is not smaller, okay, it's bigger, at least it is the size of the array, then it would return the same array. Fine, same array gets returned.
When we
Yeah.
size of 2, we updated, we want to insert 5 elements, and there will be 2 arrays, one with 12 and new one with 5.
Not one, you already had the array which you passed, so that gets changed. So array which you are passing is always updated.
So that will be updated to 5 as well. There will be 2 arrays.
No, it won't be updated. Array size cannot be changed.
We create a new copy of it, and
So a copy with 5 elements will be created. It's not a copy rather, but a new one it has to allocate. Right? New array with 5 elements. Right? Which are the 5 elements which it was the collection was having? You passed an array with 2 only. So fine, I'll put 2 elements there. So your array which you are giving as parameter is always going to be updated. Okay, let me show an example here. Okay, so if we had that collection of account CA, okay, fine, how we are supposed to use it? Okay, let me just mention it here. Collection of account CA equals, okay, and then so this is just an example here. Okay, so if we have this collection of account, what you can do is I can say, oh, I can get an account array, okay, and or even before this, maybe you already had an account array, array1 equals new, and let's say you had 7, and let me also now here itself, let me create a account 2 which has only 2 elements, okay, and this okay, five elements, okay, and let's assume this it's populated with 5 elements. Now if someone says array3 equals ca dot toArray and passes as parameter array1, right? In that case, okay, in that case, what will be happening? Array3 is same as array1, okay, no new array to be allocated, okay, whereas if I say let's use array4 here equals ca dot toArray array2, okay, yeah, so if you put this array2 here, yeah, what do you think? Array2 or array4 is not equal to array2, okay, that's one thing, but array4 of 0 is same as array2 of 0, okay, as well as array4 of 1 is same as array2 of 1. Yeah, so array2 had something earlier. Those 2 places which it has, it was having something earlier and that is lost. Okay, also let's see what happened to array3 here, array3 and array1, yeah, okay, let's check the array1. An interesting thing about array1, okay, array1 of 0 to array 1 of 4, right? Same as array 3 of 0 to array 3 of array 1 of 0, sorry, array 3 of 4. Okay, first 5 elements are same. Array 3 doesn't have more. Okay, both of them have the yeah, okay, one thing. This is fine, but an interesting, because both are the same elements anyway, this would have happened. But another interesting thing here is, what is your array 1 of 5? It was having something earlier, okay. And further elements are not updated. It's supposed to update. The array which you pass is supposed to be getting updated. If it has more space, it will fill up the initial space and put a null as a terminator. When C has null terminated strings, right? In C, you have the strings as a null termination is there. So here, it's supposed to be on that line. Okay, put everything, but to indicate the end, oh, that's the place where I've ended. So puts a null after that. Okay, so there will be a null element to indicate, oh, that's only, this is the space I have updated. Okay, and many times, now let me show you a common usage way of using, right? So normally we might use something like this: account array, account equals ca dot to array, and we might just say new account in square bracket. Okay, that's a common way of using it. Okay, and this is a common way of using it. The earlier whatever I've shown is to just understand what's happening in under which case. Okay, so you're allocating an array of the size of the collection, and so whatever you created with that new, that's what is written in account array. Okay, so that's how the toArrays method is supposed to be written. And so these are the array operations. Okay, next thing is next thing we anyway know, right? Iterator. Okay, so for that, yes, we have the public method returns the iterator of e. Name of the method is Iterator, and this we already know. Okay, fine. Now we have operations which are okay. Interoperability, right? Or oh, we call it as a bulk operation. Okay, so bulk operations, yeah, what are the bulk operations? Let's see that. So we have a method where another collection will be involved. Okay, fine. So it's working. So you have one collection and you are now interacting with another collection. Okay, it's a collection of E which we are working on, right? So we have this method to return a boolean. Name of the method is addAll. Parameter is a collection of which type of collection? Okay, so that's your other collection. Okay, from another collection, add all the elements into this collection. addAll. When clear addAll, what it does? When your collection has 5 elements, the other collection has maybe 7 elements. Okay, and you say addAll. So in the collection with 5 elements, you have said addAll and given the other one. So this collection on which you call the method, that's going to be updated. Okay, it's like if you have A and B as two kind of collections, it's like A union B, A equals A union B. We have also a method called removeAll. Any collection may be given while removing. Okay. Okay. So what do you think this is supposed to do? RemoveAll. Okay. I have a collection CA1. Okay. Fine. Which has got 7 elements. I have got CA2, which has got 5 elements. Okay, fine. And someone says CA1 dot remove all CA2. What will happen?
5 elements of CA2 will be removed from.
No.
No.
Yeah.
The 5 elements equal to same elements will be removed from.
Yeah. So one thing to mention here is, okay, they have 3 common elements. Yeah, this will remove the 3 common elements from CA1. Okay, it's like if I take in terms of A and B, okay, A equals A minus B. Okay, in set theoric terms, you can think, right? From A, remove all the elements which you find in B. Okay, now another one. So we have another public Boolean method. It says retain all. Okay, collection of question mark, and that's a other collection. Okay, yeah. What does retain all do? So if I just continue with this same example, right? Okay, if I just assume this, right? Okay, then CA1 will have the 3 common elements only. So retain all removes everything except for what I find here. Retain only this, that's what it says. Okay, retain what you find here, remove everything. So retain is like removing. Okay, okay, retaining on. So it's like A equals A intersection B. Okay, and it's an intersection, which means. And the last one, Boolean. There's a method called containsAll, and here also we are supposed to pass a collection of any time. That's a other collection. Yeah. So what does this do? Returns true or false. It doesn't update anything. Okay. No updation. Returns if. Okay. So okay, if this collection and the current collection on which you are calling contains all the elements in the other collection. Okay. It's like whether it checks whether B is a subset of A. Okay, A dot method name B. Okay, parameter is B. Okay, when it's like checking subset. Okay, so this is what a collection is. Abstract methods of collection. I have not looked at the default or the, and there are some default methods as well, but I'm currently not looking at them. Okay, there are default methods basically inherited even from the iterable. Okay, but before going to the default methods, we should actually know about some functional interfaces to understand them. Okay, so we will have to look at function interfaces, the standard function interfaces. There is a set of standard function interfaces. We'll be having a look at them also in a little later. But this is fine. So collection is fine. What is a collection? Okay, simple methods: add, remove, size, empty, contains, fine, clear. Fine. Those are the simple operations. Array related, right? Converting into an array. So object array or a array of whatever type you want, and you can pass the array as a parameter and you get back, right? The other things are interoperable. One is the iterator, giving us an iterator so that we can iterate over the elements. Okay. Anyway, for iterating over element, we have the for each loop also, and that's from Java 5. Okay. Fine. And next, we have the bulk operations. Okay. Fine. Now, okay. So next thing is a set of element E. Okay. So question: what is a set? What is a set in set theory? We've all done set theory. Definition of a set. Is that collection of okay, fill in the blank. This is collection of unique elements. Right? So what is set? Simply a collection. Set is nothing but a collection with no duplicates. And it has the same set of methods as the collection of the, right? No additional methods. There are no additional methods. Only thing here is, suppose you try to add, and if that element already exists, right? By using equals method, if it finds that there is such element already, oh, it will return false. It will throw an exception. It could do either of those. Okay. Fine. So when someone says set, that means there are no duplicates. If someone says collection, duplicates may be there. Okay. Fine. It's not supposed to have any orders. Set and collection, they both do not have any order. By saying ordered, what I mean is, oh, as you add the first element, it won't remember that this is the first element. It doesn't use indexes. Okay. What is a list? Now let's go to a list. List is a ordered collection. Okay, so when it says ordered collections, it remembers indexes. Index positions. Okay, starting index positions, you always start from 0. Okay, fine. So it has, fine. So list of E inherits methods from collection. Okay, and has additional methods. Okay, which would use indexes. Okay. Yeah. Fine.
Mostly use list.
Yeah, we may, it depends. Some places we might use list. Some places we may be having set. Okay, even sets are useful. Okay, collection is not having in the standard collection framework. For the collection interface, we do not have a class which only implements the collection interface. We do have classes to implement a set. We have classes to implement a list, right? But we don't have a class which implements only the collection. Okay, right. But we do have methods which will say I return a collection.
They also have index.
Arrays have indexes, and list also has indexes. So list and arrays are quite close to each other. But of course, there are differences. Array has only those things. When arrays will have a fixed size, list has a size, number of elements you add it. Okay, fine. So for our passbook, list would be a good candidate, right? Okay, we manage it in an array. We had to use an additional variable for index, right? To manage, to keep track of how much. If you use list, we don't need that instead of array. And so that will be our change, which will come next. Okay. And so we'll continue with the list methods. Tomorrow we'll look at those methods, and then we'll also have to make changes to the account class, right? Especially that passbook thing, and even the print passbook. We have written a for loop with the condition to check the next index position, but list would be iterable, and we should be able to use a for each loop. Okay, fine. So continue tomorrow. Yeah.